All right, today we're going to be talking about how Punnett squares can be used to predict patterns of heredity. Our goal by the end of this unit in eighth grade is actually to be able to calculate probability with a Punnett square. But first, we have to understand how to use the Punnett square. So today we're going to talk about how we use the Punnett square. The Punnett square is a graphic used to predict the possible genotypes, which, if we remember from before, genotypes are actually talking about the genetic makeup, what's inside of us, those alleles. Whereas phenotype is talking about physical appearance, what we actually see. So if we're talking about the possible genotypes of an offspring when two parents are crossed, we're talking about the possible genetic makeups, not what the actual physical appearance is. From those genetic makeups, we can tell what the physical appearance is actually going to be. For example, in this Punnett square, we have two little g alleles. This is a homozygous individual with a yellow pea pod. From those two lowercase g's, we're able to tell the phenotype is a yellow pea pod. And on the left side here, this parent is a heterozygous, meaning that our alleles are two different alleles. We can tell that we have a big G and a yellow little g, and those together, their appearance would actually be the green pea pod. So how do we actually fill this out? I'm going to just show you very quickly, then we're going to do one together, and then I'm going to have you attempt one on your own. To fill in this Punnett square, given what we are given, you're always going to drop down the top allele and bring the side allele over. You're going to drop down the side, drop down the top, and bring the side over. Now, that's all great, but we need to talk further about what this all really means. If we can fill it out, that's great, but that's only the first step. Being able to interpret is huge in determining the odds of having a specific outcome. So, here's an example. Here we're given the two genotypes of the parents we're going to cross. We have one here. This parent has a phenotype of a white flower, and the genotype for this are the two little f's. Our second parent up here on top has a phenotype of a purple flower and a genotype of two big F's. So we know the dominant big F allele will result in a purple flower. The little f, the recessive, will result in a white flower. In this cross, we have this top parent brought down here, and we have this parent labeled in our sides. Notice we only put two alleles for each genotype, and each allele gets its own box. We don't put two alleles in the boxes until we're calculating offspring. So here to do an offspring, we once again drop down the top, bring the side over. Drop down the top, bring the side over. Drop down the top, bring the side over. Every single one of these offsprings appears as though they're going to be the exact same. They have a big F and a little f. When there's a big F and a little f, no matter what the letter is, it is going to be whatever the dominant genotype is. So we said here's the big F is the dominant purple flower. So because it has a big F and a little f, we're going to go with that dominant, and all of the offspring in this cross would result in purple flowers. So now we're going to try one on our own. Here I have given you the genotypes of your two parents. You're asked to pause the video and write down the genotypes of each of the parents and tell me what that phenotype is. What is the actual physical appearance given the genotypes I have given you on the top and side of this chart? Then I would like you to go ahead and drop the top allele down, bring the side one over to fill out all 4 of these boxes. Record the genotype, which will be our letters, and the phenotype, what we think it's actually going to look like. And then you can go ahead and press play. So go ahead, pause the video, record the genotype and phenotype for both the parents and all 4 offspring. All right, so let's go ahead and walk through this. You should now have at least all the genotypes and phenotypes done for the parents and offspring. Up here, we know that our genotype is a big R and little r because that was given to us here. And we see that big R, little r, the big R is a round P. And because I have one of each, the dominants I'm going to show again. So I have a round P. And my second parent over here, I once again have a big R and a little r. And same as on top, my phenotype is going to be a round P. Okay, so now it's time to drop down the top, bring the side over for each of these. And now we can look at the phenotypes. For the phenotypes, I have 2 big R's, so you should have said, once again, this was going to be round. We only have dominant alleles. Here I have a little r and a big R, but if I have a big R present, it's always going to be whatever that dominant allele is. So once again, we're still looking at a round P here. Then down here at the bottom, I once again have one of each. So I'm going to go with the dominant round P shape. And over here in this bottom right box, I now have 2 little r's, which means I actually get to go with that recessive shape, which is going to be a wrinkled P. The only time I actually get to go with a recessive is when I have 2 of those alleles. So now, the last step is when I'm finished giving directions, I'd like you to pause the video again and draw in each of these 4 white boxes what the P shape will actually look like given the phenotype, which is the physical appearance. All right, now that you have drawn your P's, let's compare our answers. I am going to draw a round green P here. I'm going to draw another round green P here, another round green P here. When I get to here, I'm going to actually draw a wrinkled P because I have the little r, 2 little r's representing that recessive genotype. Tomorrow in class, we will actually work on calculating probability. That's what this prediction question is leading us to. So I'd like to leave you with that question and be prepared tomorrow to start working on probability of getting certain outcomes in specific crosses.